Welcome to the Explainer. So, if you've ever looked at a C programming roadmap and just felt totally overwhelmed by the sheer crazy chaos of it all, you are definitely in the right place. Today, we're taking this massive, somewhat intimidating 21-step journey, and we're going to transform it into a super clear, hyper-focused, no-nonsense path to actual mastery.
You know, so many beginners start learning C and then they just stop. Why? Well, mostly because they get trapped in what we call tutorial hell. They're blindly jumping between random videos, picking up disconnected topics, and honestly, just ending up completely lost. What you actually need is a structured sequence where every single concept builds directly on the last one. So we're going to map out a real foundation that actually lasts.
Okay, let's dive into this. We've grouped this whole thing into 5 totally digestible, logical phases. The foundation, the logic builder, the deep core, the trials, and finally, the long game. All right, kicking things off with phase 1, the foundation. This covers steps 1 through 3. Now, before we write even a single line of code, we really gotta ask, why start here? Well, C is basically the bedrock of all modern computing. Think about the operating system you're using right this very second, or the Mars rovers, or even your smart fridge. They all rely on C because it sits incredibly close to the actual hardware. Honestly, learning C makes literally everything else in programming so much easier because you're figuring out how machines actually think.
This entire workflow brilliantly illustrates the journey from raw text to a running program, which happens in 5 exact stages. First up, you write the logic. Second, pre-processing prepares that text. Third, compiling steps in to check and convert your code into machine language. Fourth, linking snaps all those separate components together. And finally, execution, which is where the processor actually brings it to life. Getting a grip on this backbone is absolutely crucial.
Moving right along to phase 2, the logic builder. This takes us through steps 4 to 6, and then 8 through 10. This right here is where we learn the basic syntax of intelligence. Every single program needs to work with information, and that is exactly where variables and data come into play. But listen, the golden rule here, truly understanding the data itself, like knowing whether you're dealing with a whole number or a line of text, is actually way more important than just memorizing the syntax. Next up, we start building real intelligence through decisions. I mean, all useful programs have to make choices, right? By using conditions, branching, and comparison, you're essentially teaching the program to ask, okay, if this is true, do X, but if it's false, do Y. This logic dictates the entire path your program is going to follow. Then we introduce loops, which are essentially your mechanisms for controlled repetition. Just think about it. Without loops, you'd literally be sitting there manually typing out instructions until your fingers fell off. Loops let your program calculate or check items continuously, completely on its own, until a specific condition is finally met. Now, as your programs inevitably grow, you really have to organize all that logic. That's where functions step in, letting you break massive, overwhelming problems down into manageable single-job units. From there, you manage information flow, basically passing parameters in and returning results out. And finally, structured data lets you group related, real-world records together, kind of like linking a student's name directly with their grades. This is the exact recipe for building clean, modular, and stable code. All right, things are about to get slightly more intense. Welcome to phase 3, the deep core, covering steps 7, 11, 17, and 18. Now, what's really interesting about this concept is the massive difference between a code writer, who only focuses on basic syntax, and a true software thinker. A software thinker actually understands memory, pointers, and the difference between the stack and the heap. Memory is the absolute beating heart of computing. Knowing how to actively manage it is the exact thing that elevates a beginner into a bona fide expert. But we can't just rely on temporary memory forever. You have to learn how to store data permanently in files, how to avoid those absolutely dreaded memory leaks, and how to master OS interaction, stuff like handling keyboards, screens, and external devices. Interacting directly with the operating system is what actually transforms a basic script into a genuinely powerful real-world application. That brings us to phase 4, the trials, encompassing steps 12 through 15. This is the application phase. It's where you take all that theoretical knowledge and transform it into real, tangible skill. You build confidence entirely through projects. It's best to start small. Build simple calculators or timers. They honestly don't need to be complex. They just need to be finished. And then, once you're comfortable, you step up to medium, real-world projects like an address book or a billing system. Those are the ones that really teach you vital skills like planning, file handling, and error management. Now, during these trials, you are going to encounter bugs. It is completely unavoidable, so just embrace it. But debugging isn't just some frustrating hurdle. It's actually about building discipline, patience, and absolute clarity by fixing incorrect behavior. Learning how to properly read an error message and hunt down the exact source of a crash is arguably the single most important real-world skill you will ever develop. And finally, we arrive at Phase 5, the long game. This covers Step 13 and Steps 19 through 21. As you polish your skills for the professional world, here is a crucial point to remember. Optimization is not about writing tricky logic. It is about writing clear logic that performs well. Sure, C gives you incredibly fast execution and a wonderfully tiny memory footprint, but you achieve that through simplicity and predictability, not by trying to be overly clever with your code. These final steps to mastery really combine advanced learning with solid professional habits. You'll dive into data structures and algorithms so you can organize data efficiently, and you'll learn to use compiler flags and environments effectively. But you know what the real secret is? Daily practice, building and documenting a solid portfolio, and eventually sharing your knowledge to teach others. For sure, your portfolio is your absolute best ticket to landing real interviews and jobs. Ultimately, learning C is so much more than just writing code. It literally teaches your mind to think logically, to design intuitive systems, and to deeply respect performance. It genuinely forces you to adopt an entirely new mindset, which makes it the ultimate starting point for a lasting, successful career in tech. So after seeing this true, focused path to mastery, are you ready to think like an engineer? Thank you so much for joining me on this explainer. I really hope this roadmap has cleared the fog, sparked your curiosity, and left you totally eager to start writing your very first lines of C.